Good morning, guys, and good day, good afternoon, good evening. This is jwsolarusa. This is the system, and I was just gonna do a short video on load test. This afternoon now here in Minnesota is 13:21 hours, and this is the one of the freezers running. I was gonna stop, but I don't want to interrupt. But I stopped some of the things so that they can able to give you the amount of load the entire system is going to be pulling at one point. So we're going to be doing a test here, 1800 watt Kettle and 1800 watt Kettle and a refrigerator, rice cooker is cooking, and the water dispenser. They're all gonna be running simultaneously. Right now the deep freezer is running, and it says only pulling about 3.2 amps. Before I about to do the video, it was pulling about 20 some amps from the batteries, which my batteries up till now, guys, I just want to let you know that I haven't connected the solar. I turned the solar off. I'm still studying the system, and I let the batteries go down 7% of state of charge, which 70% is not the way I look at things. It's not like I'm looking at state of charge. I'm paying attention to more of the voltage. So right now you can see this is the amperage we've been pulling all night. So it runs all day yesterday, all night. And we only pull about 67 amps out from the batteries on the 6 kilowatts, and this is the state of charge, the battery voltage currently. So you see that 29.6. so I charged them up to you guys saw the videos on 31.8 something. So it runs about 24 hours plus. And now it's 1 o'clock, and the batteries are not connected to the grid up to this time, and we are only sitting at this state of charge right now, which is here. It is 68 amp hours, which I have plenty of power in the batteries. This just like that. It only took that from the batteries. So the state of charge I was been looking at is not that much important when it comes to lithiums. That's my opinion. But the voltage is one of my greatest thing here. I'm watching, and you guys can see the voltage is all, since we turn on the system, guys. This is what we already draw from the system. These are all the numbers. And we charge up to about 100%, and that's what I saw the max charge when I program. So, and minimum cutoff, and that. So I just want to give you a full blast of everything here. These are the amps already taken out from the battery since the system was turned on. So let's do the test now and see how much amps. So I'm gonna tell my wife to because we turn the breakers off, make sure that they're all gonna be together at once, and from there I'm gonna be turning the Kettle here to get everything run. Okay, stay tuned. Here is the disconnect from the main breaker panel. Coming to the inside here, I have another disconnect here that I put in here. So it's down right now. It's not up, it's down. So it's disconnected, so it's not like any cheating games going on here. It's disconnected. It's not powered to the grid. Okay. Alright guys, are you ready for this? You're gonna see the spike fridge and water dispenser, the rice cooker, and after that the Kettle is coming on. Alright, do it. Honey, go ahead. There we go. See the spike? 103. Just told my wife to turn the switch. The spike went up to 103, and the tea kettle is coming up now. There we go. So we're pulling about 78 amps right now, almost 80. So all these things are running simultaneously. The fan just kicked in. You can hear it. Check the rice cooker. And we are doing, let's check the voltage now. The amps don't go anywhere. And these are the volts. Right now, sitting at 28, we start at 29 point something. So we pull in 98 amps. Everything is running. Guys, do the calculation. Calculate, multiplies 28.8 times 98 amps. The surge started at a 103. I hope you got that. And the inverter is going. No sag on the batteries at all. Was 29 point something. No sag that much. Look at that. What's going on? I just want to show you the power of lithium. If you don't trust lithiums, it's about time for you to start. And if you haven't made up your mind, because like me, I was dragging my tail, I was dragging my butt not to do this, and because of the expensive. But look at this, we just lost 1% of the state of charge. Now it was 68, now it's 67. That's really awesome. And look at the batteries. You saw the voltage we started at. Rewind that and see it again. And right now we are about 82.4, 82.8 amps. We pull in respectively from the batteries. So you can hear the fans running. And I want to prove it to you. No solar, no charge controller is on. See that? Nothing is on. To say maybe we're backing up with the solar. All the meters are off. The only thing is the surge protection. You can see the breaker is off for the AC to charge the batteries. And you can hear the fan running. Magnasine is just doing its stuff. Okay, and if I was charging, you would see the light indicating there the charge, but it's not charging at all. The breaker is off, and we're pulling 82.4 amps constantly, continuously. So look at that. Remember the amp hours that we had before. I told you we took from the batteries. I can't remember anymore. I think it was 60 something, 69 or 68, whatever. But look what's going on here. Just want to show you. So now you can see all the surge, everything started. We are down at 66 amps. 66%. I think we were 68. Suppose you can pause the video, rewind it, and see everything is running. I just want to make sure that the tea kettle, you know, shut off again after the water is already boiled, and you see, and the amps are dropping. We were 80 something, 82, 84, and amps are dropping because all the surge, the loads from the refrigerator, freezer, and water dispenser with water heater built in it. But I just turned the water dispenser, the cold water, not the refrigeration part of it, not sorry, what is it? Not the heater part. So we pull in power. So in as much as I don't want to miss this action, you can see when the tea kettle drops, calculate or subtract how many amps already off. You see a big drop. 1800 watt tea kettle. Let's see. I don't want to miss this at all. I don't want to blink. I want you to see it. I can smell the rice, the aroma right now because it's cooking. I can smell it from the kitchen. So I can hear the tea kettle is almost like getting done. I wish I would have give you a quick glance of the tea kettle, but it's running. I don't want to stop right now and go show you, but just watch. It's gonna kick off. Getting there. It's getting there. So these are all my heavy duty stuff in the house I'm using continuously in the house, but they come and go, they recycle. They're not running constantly. No break has popped yet. Nothing. I can hear the tea kettle. Water is boiling. I don't want this video to be long, but hey, I want to prove things. It's getting there. I don't want to pause the video, nothing. There we go, it just kicks off. Look at all the amps that it was bringing. 68. So subtract 68, 11 out of 68. So now it's just the freezer, the fridge, the water dispenser, and the rice cooker. You see how efficient my system is? You see how efficient my machines are? So the tea kettle is the killer, and you can hear everything is whining here. The fan is winding down from the inverter, and no solar, everything is off. The inverter is gonna stop soon, and take a look. It's 11 amps only. A deep freezer, a family size refrigerator, and water dispenser, a rice cooker. Okay, this is how efficient my house is. So I am not burning too much power because of all the appliances I have. I change all the junk. That's I'm gonna advise you, take all the junk from the trunk and get your house very efficient. A word for why is this sufficient? This all complete my test today, and thank you guys for watching. And just want to show you the power of lithium live here at the JW Solar USA. You have a blessed weekend. Bye for now. Alright guys, this is the tea kettle right here. The water is already, woo, it's hot. I can flip the switch again so that you can see. See that? Okay, it's already boiled, so it's gonna kick off again. Alright, thanks. Yeah, it's the freezer. You see all the blinking? It's going. You guys can hear in the background. And that's the settings right there. And you guys have seen the water dispenser, PRIMO, and it's Energy Star. That's how I was telling you, promoting all energy efficient. There's a light right there. You can see it. LED. And you see the rice cooker and everything. The rice is ready now. Look at that. Beautiful. Oh boy. Nice. And that's the plug-in for the refrigerator. Fridge is running. There you go. Here's the water now. We already put it into the thermal flask. So we save the water. So we just, anytime we need tea or anything, we just keep pushing the top here. This is how, just these are the commercial grade. Keep compressing this handle to get water from the dispensing machine. So here's a sample for you. It's coming out brewing hot water. Look at that. Alright guys, thanks for watching. Love you guys all. Subscribe and share. Guys, I just want to show you After all the dragging, it's about 28 point something volts, and look at that, the voltage went back all the way up to 29.17. So went back to 29.1, and we're sitting at 64%. So it's nothing for lithiums. We pull in 11.2. Rice cooker still finish up, like you saw everything. Give you a tour of everything, and the hot water, put it back into the thermal flask, and water dispenser is still running, the freezer and the fridge, the rice cooker. The only thing that is out of the system right now is the kettle. So we subtract 98 amps, subtract 11 minus 98. So what is that? You see, that's a lot of power that the kettle's taking. Thank you so much, and love you guys, and stay tuned for more to come. And I'm going to be starting up a new series here soon. Stay tuned for that. And as we already round up with the test, I'm comfortable, and I think we have to move on now to another level instead of talking about this over and over, because you guys want to see the load test, you guys want to see how the system is running, and trust me guys, the system is running good. I'm really pleased and satisfied. Thank you.